Welcome back. Today we're going to talk about intervals and extrema. So in math we use interval notation to describe the x values on which the y values are either decreasing, increasing, or they are constant. So what we really need to remember is that these are talking about open intervals. So we do not include the endpoints. All right, so what we are looking at with this picture is what are the y values doing? So we're going to look first at where they are decreasing. So the y values are decreasing in this little section here. And then you're going to say what are the x's on which those occur. And these are decreasing. The x's all the way over here are negative infinity, going all the way to this x, which is 2, and then we put parentheses. Okay, so where are the y values increasing? So my y values are increasing here. So then again, what are the x's in which those occur? So this x is 5, and then the x over here, we have an arrow, that is infinity. And then where are the y values constant? So the y values are constant, they do not change right here. So again, this is 2 going to 5. Okay, when we talk about extrema, we're talking about the highs and the lows of a graph. Okay. Now you're thinking about a relative maximum or minimum of a function. It's either the greatest, so the highest point, so that's my peak, or it's the least, imagine it like a valley, that your function can attain on a certain interval. So just on some interval, this is what our function can attain. So these relative maximum and minimums are really our turning point on a graph. So where is the graph changing? I mean, they're increasing, decreasing, maybe it has a constant. Now, if you have a relative max and min, and that happens to be the greatest or the least value that your function can attain over the entire domain, that is known as the absolute max or min. So this is the highest or the lowest value over the entire domain. So let's go ahead and look at some graphs together. Okay, so here we have a function. If we graph it in our calculator, we can find the domain, the range, and we can also find the zeros. So let's just go ahead and give you a rough sketch of what this is going to look like. So it is an upside down parabola. We do have some zeros. And remember, those are just our x-intercepts. We do have a high point. And these are some things that we want to keep in mind of our graph here. So this high point, which we know is our vertex, occurs at -5 and 4. Now our x-intercepts, or our zeros, there are 2 of them, they occur at -7 and they occur at -3. So these are our 2 values here. All right, so when we look at our graph, we're going to look at what is our domain. So we're looking at all possible x's. So we've got arrows, so we have a -infinity to +infinity when we're talking about our domain. And when we look at our range, we're looking at the y's. So we're looking at where is the bottommost y to the topmost y. So the bottommost y is -infinity. And the very topmost y happens to be our vertex, which is at +4. Now we're also going to ask you whether this is an even, or if it's odd, or if it's neither. So the way that you can look at this is, again, remembering how do we figure out our even and odd functions and the symmetry. So is this graph symmetrical around your y-axis? No. Is it symmetrical around your origin? No. So this one is a neither. Okay, the next thing we want to do is we want to look at our interval. So increasing, decreasing, and constant. So again, let's go ahead and look at what we have. So when our y values are increasing, what is the x interval? So here my y's are increasing in this little section here. So what are the x's that when your y is doing these? So this goes from here, negative infinity, because you have an arrow, going all the way to this point right here, which is at -5. Okay, when we're also looking at decreasing, we're looking at, all right, so what are the y's doing? So we're starting here, y's are decreasing. Okay, so then again, what are the x's in which this is happening? So we go again from here's the x, right at -5, going arrow towards the right to positive infinity. Our graph is not constant anywhere, so you could just put none or just put a slash through is fine. Okay, so let's talk about what's going on with this vertex. This is called the absolute max. So that is the highest point in the entire domain that your function reaches. There is no relative maximum. We don't have any other hills anywhere. And we don't have an absolute min, and we don't have a relative min. We have only arrows at the end. All right, so let's look at one more here. Again, we're going to just give you a sketch of what the graph will look like. And again, remember, it's just a sketch, so we're going like about here. It may not be 100% accurate. So there's like our sketch. Again, we have some zeros here, here, and here. And our first zero is at -3.46. We had another one at 0, and we had one at +3.46. Okay. We do have 2 points that are important. Now, for our 2 points here, our values are -2 and then 5.3. And then we have 2 and -5.3. So there are our values. There are the coordinates to those points there. So let's just look first at what our domain and range is. So my domain, we got arrows pointing in both directions along the x's. So we have -infinity to +infinity. For our range, again, arrows pointing in both directions for the y. So we have -infinity to +infinity. We are looking to see if this function is symmetrical around your y-axis. No, but it is symmetrical around your origin, so this is an odd function. And now also let's go ahead and see what's going on with increasing, decreasing, and constant intervals. So we're going to look at increasing first. So where are the y's increasing? So y's increase up, 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 up here, and increasing from down here, up, 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 up. So let's figure out what those x's are. So here we have -infinity because we have an arrow. And then here is the x, which is -2. When you have more than one, just put a comma. Then we start this pink section at 2, going all the way because you have an arrow to infinity. Okay, now we're going to look at decreasing. So my y's, they kind of start here, go down, 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 down. And what is the x in which it occurs? Here we're starting at -2, and the x is going to +2. Again, for this one, we don't have any place where our graph is constant. Now, the 2 points that I gave you the coordinates for, these are important. So the very first one we have, this is called a relative max. So it's not the absolute maximum because we do have an arrow here, so we do have infinity, but it is in a certain part, it is the highest point. Okay, it is in some interval of your domain, it is the highest point. It's not the absolute highest, but it is the highest point. And the other coordinates we gave you, This is called a relative min. Again, it's not the absolute because you have an arrow that points down towards infinity, negative infinity, but it is at some point in some little interval on your domain, it is the lowest point or the lowest value. I hope this video helped you identify intervals as well as extrema on graphs. Thanks for watching, and we'll see you next time.